Welcome back. We're going to take a look at the first section of Chapter 2, Frequency Distributions and Their Graphs. That's the first section. There are 5 sections. This is number 1. So these are the things you're going to learn in this lesson. And don't forget, you can hit pause anytime, especially when we get to a question. Hit pause, try it yourself, and then move on and see if you got it right or not. It's a good way to learn. So we'll talk about frequency histograms, polygons, histograms, and ogives. Ogives. That's how it's pronounced. All right, let's start with frequency distribution. And what I need to do first here is make sure the pen's running. There we go. All right. We're ready to go. All right. So this table shows a frequency distribution. And what does it represent? Well, we've got classes over here, and usually the class is a spread of a particular set of numbers. You can see it goes by 5s here. And on the right-hand side, you see the frequency, or how many were in that class. So in this particular set of data, there were 5 items that were somewhere from 1 to 5. Doesn't matter where, just somewhere. In the 6 to 10 section, we've got 8 items. That's what frequency is. And usually what you do when you're trying to set this up is that you set up a table and you go through the data one at a time and see which class they're going to fit in. In that class, you'll put a tally mark, and when you've gotten through all the data, then you go back and see how many tallies are in the first class, how many are in the second class, and so on. So frequency is how many data items are in the class. Now, in that class listing, you've got lower class limits. Let's see, it's here. And you've got upper class limits there. So of course, it means anything in your data from 1 to 5 will be part of the first class. Anything from 6 to 10 will be in your second class, and so on. Pretty simple. Notice, though, that they don't overlap. The first class is 1 to 5. We start off with 6, starting out with the next class. It goes to 10, and we start with 11 in the next class, and so on. Class width, very simple. You can take any 2 numbers in a row of the limits and just subtract them. The easiest is just take the first 2 of the lower class limits. Subtract 6 minus 1, your class width is 5. Notice also that not only is 1 to 6 5 apart, 6 to 11, 11 to 16, and so on. Even the upper class limits, 5 to 10, 10 to 15, and so on. So once you get that first one, and you know what the class width is, it's just a matter of adding and making sure you don't have any overlap. The difference between the minimum and maximum is called the range. So range equals max minus the minimum. It's that easy. Just subtract them. The biggest number minus the smallest number, and that's the range. That's the spread of your data in one way of looking at it. Now, how do we get started on this? Well, first of all, you have to decide how many classes you're going to use. Note that it suggests here that when you pick the number of classes, it should be anywhere from 5 to 20 classes. And maybe you're wondering, okay, what if I want to pick 11? That's fine. What if you want to pick 13? That's fine. It's up to you. And when you get finished with your frequency distribution and looking at maybe a couple of charts, and you decide, you know, I should have had a different number of classes. Maybe I needed more. Maybe I don't need as many. This is an artistic thing almost. It's your choice. But you might want to try several to see if there are any patterns that show up in one particular number of classes. Class width. To find that, you start with a range. Remember, that's maximum minus minimum, gives you the range. Divide the range by the number of classes. So if your number of classes is C and your range is R, then the class width will be width equals the range divided by the number of classes. If it doesn't come out even, which it's unlikely to do, round up from whatever you got. Round up to the next integer. Next, the class limits. You saw them before with this group. And one simple way of starting is use the minimum as the beginning of your first class. So it looks like this. Your frequency is over here. Your classes are over here. And you'll start off with a minimum, usually right there. And then you'll add the class width to get the next one, add the class width to get the next one, and so on down until you've covered the entire range, and you'll be covering all the data that you've got. Fill those in. We're going to have a picture coming up here that'll really show it. The same thing works for the upper class limit. Remember, they can't overlap. That's the key. So once up here, where am I? Lost my pen. Where's the pen? Okay, so there we go. Okay. Up here, you got the minimum. Make sure that the number here and the number here are consecutive integers. So if this is a 19, that'll be a 20. If this is a 25, this one will be a 26 over here. Fill in those class limits. Then look at your data. Which class does each fall in? Make a tally mark. That's what your table's for in part. Count the tally marks to get the frequency for each class. We'll see an example. So here are some data. 30 US adults, and this is the cell phone screen times. No value judgment here. We're just talking about data. Now we're going to create a frequency distribution. Frequency distribution. Well, can you figure out what is the first thing we're going to do? First of all, decide how many classes. So this time, we've decided we're going to try 7 classes. What's next? Find the class width. What is the class width? Divide the range by the number of classes, and then don't forget at the end, round up to the next integer. So you'll actually go from 35.71, next integer is 36. Next, the minimum value is 155, so we start the first column with 155, and then we add the class width, which is 36. That'll give us the next number down, add 36 to that. We're next, add 36, add 36, add 36, add 36. And you're almost done. All you have to do now is figure out what the upper class limits are. And that is easy. If this class right here starts at 191, then the previous one ended at 190, one less. Oops. And once you have the 190 up here, you can actually go by those 36s, just add 36 to 190, and you get the next limit. Add 36, you get the next, and so on. Once you get started and you know the class width, it's easy. It's a real breeze. So remember, since you've got the lower limits already, each of these lower limits tells you what's going to go in the upper limit in the preceding class. 227, one less, 226. 263, one less, 262, and so on. Fill those all in, and then you're ready to take your data and see which classes which class it fits in. So make a tally mark. So someone has already looked at the data that you've seen earlier, and they found that there were 3, so the 3 tally marks, and that's the frequency for that class. In the next class, there were 2 data items, and that's the frequency for class number 2, and so on down. Now, one real good check for you at this point is add all those frequencies. In this case, 30. This number right here should be how many pieces of data you've got. So that's a double check to see whether your tallies are correct. If not, erase the tally column, start again, because you don't know which one is in error. Now, the midpoint of a class. Well, it might not be obvious what we'll use a midpoint for, but this is a skill we'll just pick up and we'll use soon. All you do is add the lower class limit and the upper class limit from a particular class. These are from the same class. Add them together, divide the sum by 2, and that's the midpoint of your class. Examples coming up. So for the first class, it starts at 155, goes to 190, add those, divide by 2, the midpoint is 172.5. Next one, real easy. Actually, you can do that the whole way down, but there's an easy way to doing it. If you want the midpoints for all of them, once you get the midpoint for the first class, remember the class width was 36? Add a 36 to that, and you'll have the midpoint for the next one. Add 36 to that one, and you'll have the midpoint of the next class. Yes, it is easy. All these are really easy, but there are a lot of them. So take good notes. And so on. Next, relative frequency. Relative means what is the frequency of a particular class compared to all the data. So that relative frequency, you take the class frequency for whatever class it is, first, second, third, fourth, or whatever. There's a frequency for class I, let's say, 1, 2, 3, whatever. And divide that by the size the total size of the sample. All of them should be the total of the frequencies. So for one class, how many are there in there? How many are there in total in your data? That gives you your relative frequency. And if you do a little bit of thinking, you might realize that it's always going to be somewhere 0 up to 1, usually in between that. Special note, that number down here, as I mentioned, is the total of all the frequencies. And you double check to see that was the number of data items you had. Next, cumulative frequency. It's another item to remember, but as I said, it's by itself, it's very simple. It means what is the total of the frequencies from the beginning of that table up to and including that class. With a little picture, you'll get the idea. And when you get to the last class, your cumulative frequency should be the total number of data items you've got. So let's take a look at some of these. How do we get them? So, first class. Here's the frequency. You want the midpoint, add the two numbers, the lower and upper limit, divide by 2, and you've got the midpoint. Relative frequency, there are 3 in this class, 3 items. There's a total of 30 of all the data items. Just divide them, and these are listed not as fractions, but as decimal fractions. So you'll see usually 0 point something for each of the relative frequencies. And we haven't talked too much about the cumulative frequency, but you're going to find out it's really easy. So notice that there are 3 in this class. That means up to that point, this is the first one, it's just 3. Now the second class, you've got 2 items. And what you do is you take that 2, add it to the 3 you have here, and you get the cumulative frequency. The cumulative frequency is how many you have up to that point in the table. For the next cumulative frequency, here's a frequency we're going to add to the 5. And there's our cumulative frequency for class number 3. The next class has 6 items, so you add it to the last number you got, and there's your 16, the cumulative frequency. That means all the items from the beginning of the table up to and including that class are this cumulative frequency. And the last class, or the next class, has 7, so we add the 7 to the 16, and there's our cumulative frequency for that class. And there's a good summary for you. A couple of things to remember. And double checks, you might say. When you've got all the frequencies, add them up, see if this number is the number of data items you've received. Second, if you want to make sure the relative frequencies are probably okay, add up all the relative frequencies. You should end up with exactly 1. And third, cumulative frequency, remember, it's how many are in that class and the ones preceding. So it keeps getting bigger and bigger and bigger. The first one is just for that class. When you get to the end, it's going to be the total of all the items in all the classes. So this is, again, n. Well, there's some patterns. One of the good things about creating frequency diagrams, frequency tables, is that you can look at it and your eyes and your brain tell you some things. For one thing, you can create a frequency histogram. On the bottom, you put the data values or class, and each bar will be the height it needs to be according to the y-axis. So this height here will be how many items are in this first class. This will be the height of the second class, and so on. And your eyes can see that the one in the middle has the most data items, or the greatest frequency. The horizontal scale is quantitative, that means numbers. And those are the data values. And the vertical scale is the frequencies. Both of them will be numbers. Now, one thing about histograms you need to remember is that for a histogram, those bars that you make have to touch. Take a look. This bar touches this bar, this one touches that, and so on. There are no gaps between bars. Class boundaries. Okay. Well, we're thinking about the classes, and if the data come in distinct units or distinct integers, you're okay. But if they're continuous variables, if you could have decimal values, then you have to get class boundaries, because just saying 155 to 190 won't really do it for you, because the next one starts at 191, remember? But what if you had a data item that was between 190 and 191? Say, for example, suppose your data item is 190.7. It's going to fall between those classes. That's not good. So we create class boundaries. And the way we do that is we take these, let me clear that. There we go. Okay. So we've got the classes, and we need class boundaries. We want to make classes, change it to classes where there are no gaps. A picture will help right here. So the classes we began using were 155 to 190, 191 to 226. That looked pretty good, as long as the data are integers. If they aren't, then we've got gaps. So what you need to do is close that gap. So between 190 and 191 is a gap. So instead of ending class 1 at 190, you're going to take the 190 and 191, add those, divide by 2, and that will give you the new class boundary. The 190.5 will be the upper boundary for this, and the 190.5 will be the lower boundary for this one. And again, when you want to get the other boundaries, just add 36, the class width. Do this 2 times, and this will be easy, really easy. Remember, what I said, there are a number of things in this section, but they're all simple. There are just a lot of them. So here are the class boundaries. So if you look here, From 190 to 191, we had a gap. Now we don't have a gap. Any number that you find in your data has to either fit in this class or this class. The distance from the upper limit of the first class to the lower limit is 1. Halfway is 0.5. So first class boundary. On the other side, so we got that 190.5. Here we go. We've got the 190.5. Well, notice what we did. We just bumped this boundary up by 0.5. Well, if we want a class boundary for this first part, so all we do is we take the 155, subtract the 0.5, and there are class boundaries for the first class. You're closing the gap so that no matter what data you pick, it'll have somewhere to go in that table. Once you've got the boundaries for the first class, you're in business, because all you have to do is add 36 in both columns to get the other boundaries. Now here are two examples of a frequency diagram and two ways of doing it. In this first one, the one right here, when they went to make a name for that bar, they used the class midpoint. Class midpoint, all the way across. And you had hash marks in the middle because that's the midpoint. But another way of doing it is to use the actual class boundaries. All of the data starts at 154.5, so that's the beginning of your first bar. The next one starts at 190.5, that's the beginning of your second bar, and so on across. So by looking at it, you can tell about 2/3 of the adults are spending more than 262.5 minutes a day using their cell phones. This is just looking at it and using your logic and what you're interested in. Now, frequency polygon. Let's sneak back here for a minute. If I wanted to create a frequency polygon from this, imagine that you did all of this in pencil and you wanted a frequency polygon. First of all, you'd put a mark at the top in the middle of each bar. And you're going to add two more. Now notice this is halfway, so you'll go down here and you'll put another point. That means there's 0 in this bar, and over here you'll have 0 in the last non-bar. So your frequency diagram will start at 0, go up to the first point, second point, third point, and so on with straight line segments, and ending up back on the x-axis. Starting on the x-axis, ending there. Each of the midpoints of the bars, tops of the bars, are vertices for your polygon. So there's the finished product. So you want a frequency polygon for that one? No problem. And there you got it. You might want to try doing this yourself. Not right now, but come back and get the data, try it yourself. You got the midpoints right here, and you got 0 points. Here's the starting point, which is just to the left of the first bar, and this 0 to the right of the rightmost bar. Remember, start on 0 for the first point, go up to the first midpoint, second, and so on, and finish up at the bottom. And you've got your frequency polygon. Now, one way I sometimes like to tell people is that, we'll go back here. Imagine that you created your histogram. So you got your histogram. Imagine you did it in pencil, easily erasable pencil. And then you create your polygon. And then to finish it off, you go back and erase all the bars. And you've got your frequency polygon. That's the way I like to think about it. You can choose whatever way works for you. Don't forget, you start on the x-axis. Where's my, there we go. Start on the x-axis, end on the x-axis for your frequency polygon. You can also do this on the TI-84 Plus. All you have to do is put the numbers in your calculator, and that's stat, edit, put them in list 1, 2, 3, 4, 5, or 6, and then go to stat plot, turn on one of them, turn off all the rest, and hit graph, and you'll get something like this if you've chosen a histogram for the picture. Well, we don't have enough histograms yet, do we? Well, the one you saw before had the data values across the bottom, the same here, but the one you had before had frequencies for each of the bars over here. In this one, instead of frequencies, we've got relative frequencies. Remember those decimal points? And remember, they all add up to 1. Well, if you make this axis those decimal places, like maybe we'll make, let's say this one was 1.0, maybe this is 0.9, whatever. And then you make your bar graph. The funny thing is, the relative frequency histogram is going to look just like a frequency histogram. It'll be the same picture. Your brain will say, wait, this is the same thing. What are you doing? Well, you just have a different look, because maybe you have a reason to have a relative frequency histogram instead of a frequency histogram. It's your choice again. Yes, there is an artistry to statistics. Believe it or not, you have choices. Want a relative frequency histogram? There's the frequencies. And the relative frequencies are used for this one. Notice that on the left-hand side, you've got the values for the relative frequencies. And each bar is as high as the relative frequency for that class. Also, one other thing, sometimes with one like this, you might have the number of items in this one. Let's suppose there are 4 items in this bar. You might put a 4 up there. And maybe this is a 3, and so on. There are lots of ways you can sort of juice up the histogram so you have more information on it. Now, back to the cumulative frequency. Now remember, with the cumulative frequency, you keep adding the frequencies until you get the total. And that's what it's going to look like when you make a frequency distribution graph. It starts down here because before the first bar, you have none of those data values. With each successive point, you've added up all the data items that you've got up to that point. When you get to the last point, this should be as high as the number of data items you've got. Or if you've got a relative frequency, cumulative relative frequency, then this one would end up being 1.0, the whole thing, also known as 100%. The upper boundaries on the horizontal axis, and so on. Constructing an ogive. So, first of all, how do you pronounce it? Ogive. Ogive. The accent on this one, and you know how to speak ogive language. Now, all you need to do is you're going to create, imagine you create a bar chart. Anyway, that's not a very good bar chart, but you've seen enough at this point. What you do for the ogive is you rearrange those bars so the one that's highest comes first, and second highest comes second, third highest goes second, so your bars are going down like this, bar-wise. So there's one bar, there's another bar, and so on. Now, one reason for adding this is, and you might think it's silly to create another bar graph when you've already got one. Well, the reason for this is, with an ogive, your eyes are going to look at the first bar first. And that first bar is going to be the greatest height. It's probably the most important, the one that needs your attention. And there's steps you need to follow. Connect the points. And there's our original data. We've got our class boundaries and the frequencies and the cumulative frequencies. So the left-hand side has the cumulative frequencies up to that bar, and the last one should end up at the total number of data items you got, also known as 30 in this particular example. Well, we could use technology to do this too, and that would be a lot easier, wouldn't it? Well, it's good to know how it's being constructed. Even if you use technology, you ought to know how it's put together. So that's why we're going to all this effort. Here's how you do it on the TI-84 Plus. You know where the stat key is, perhaps? It's somewhere toward the middle. If this is your TI-84, that's not a very good calculator, but you're not buying it. The stat key is somewhere around there. You can find it pretty easily. So to begin, you hit the stat key and then enter. And what you're actually doing is when you hit stat, by hitting enter, you're actually going to edit mode. Stat gets you to a menu, enter gets you in edit mode. You put the midpoints in the first list. Now you don't have to put in L1, but let's keep it simple. Use L1 and L2, L3 most of the time, and you'll be happier really. So you put the midpoints in list 1, one after the other. Put the frequencies for each of those items in L2. Double check, make sure that what's in L1 and what's in L2, these two pieces belong together. This says what the midpoint is. This tells you how many are in that particular class. Next midpoint, how many are in that class, and so on. Make sure when you're finished that these numbers are correct. One way of checking right away is make sure these columns are the same length. If you've got 7 items in the first column, you should have 7 over here. If you have 100 over here, you should have 100 over here. Exactly the same. Now let me clear this so it's not quite as messy. There we go. Okay, after you put in the midpoints and frequencies in L1 and L2, then we're going to go to another different place. And I'm going to see if my picture looks maybe a tiny bit better. Maybe a tiny bit better. Up here is your screen. And the key right up here is stat plot. And what you want to do when you get to, you hit second stat to get that plot, you're going to turn on plot 1. And if there are any other plots, turn them off. You don't want more than one plot on the same picture. It'll just mess things up and you'll get confused. Highlight the histogram. That's the third icon in the plot menu. Make sure you put XList as L1. This is for the data items. Where's my cursor there? These are the midpoints of your classes. And this is the frequency for each of those classes. Put those in, and you could just hit graph, but a lot of times you don't get much of a good picture. So the best bet is to hit zoom 9. And if I remember right, zoom 9 means stat zoom or something like that. In other words, it looks at the data and says, okay, what's the best way of showing this information? And you get a good picture. In this case, a histogram. Something like this. And because you've hit that zoom stat plot, then you get one where you see it from left to right. There's no extra space and there's no gaps. And you've got a good idea what the data looks like. Remember, the height of the bars represents the frequency, and the numbers across the bottom will be the midpoints for each of the classes. If you want to see what those midpoints are, hit the trace. And what you'll see when you hit it at first is you'll see the sort of a cursor-like thing at the middle point of the top of the first bar. And if you move your cursor by using the arrows to the right, that's going to move over here. Do it again, it'll move over here. And while it does, you'll get some information here. You're going to get what the minimum is and what the maximum is as well in that particular bar. Just the right and left arrow keys to move the trace from one bar to the next, or backwards if you like. Now, we are not using Minitab or Excel. Both of them are excellent. I've used both of those. In fact, one year, about 5-10 years ago, I taught one statistics class using just Minitab. It was quite a learning experience for me, but it worked really well. In Excel, of course, most computers have the spreadsheet Excel, and you can do the same thing in there in a similar way. And there's another possibility. Your textbook sometimes comes with an application called StatCrunch. And of course, you'll do the same thing as you did previously here. putting the numbers in and so on. And just hit a couple of keys and you get a histogram. Well, you made it through section 1 with frequency distributions. I hope you've learned a few things. You'll have to review and make sure you have good notes. Because if you need to do one of these things or you look at one, you need to know what it represents and how it's put together. Well, take care, and I'll see you in section 2 too. And we'll carry on. Keep smiling.